Welcome everyone to our live office hours. I'm glad to have you joining. And today we have a bit of an experimental approach, but more on that later. Because first Marco, who works as a software engineer at Kubermatic and is also a Kubernetes release manager, will share his insights and updates on the Kubernetes project. After that, I will show 3 recordings that we recorded for a virtual event, which actually then never took place, but that we still wanted to share because it basically shows everything we ever did at Kubermatic in a nutshell. The first part will be on why to write operators for Kubernetes. The second one on implementing, monitoring, logging, and alerting stack for a distributed platform. And finally, we have a small clip on how to write software that sets up Kubernetes anywhere. This means we have kind of an inception mode this time, so where we have recordings in a live streaming. I'm curious to see how that goes. But of course, we have all our technical experts with us. So please put all your questions you ever had on Kubernetes or on Kubermatic in our open source project in the YouTube channel, and then we will pick them up and answer them after the recordings. Yeah, and with this, I want to hand over to Marco.
Hey everyone, thanks for introduction, Chrissy. I will share my screen. And I hope that you can see it. Today, I'm going to talk a little bit about the Kubernetes and the latest updates. First, we are going to start with a short recap of what's new in Kubernetes 1.21. Kubernetes 1.21, called Power to the Community, is the first release of 2021. There are 51 enhancements included in this release, so there are a lot of interesting changes. And in Kubernetes Platform 2.17 and KubeOne 1.2, we already support Kubernetes 1.21. So if you want to try it, you can go ahead. Some of the highlights is that we have the graceful node shutdowns graduating to beta. This is interesting, and it ensures that kubelet is going to gracefully shut down and terminate all pods in the case the node is going to be shut down. And this can be very interesting in combination, for example, with the preemptible instances on GCP or spot instances of AVS. Next one is that immutable config maps and secrets are now stable. So you can specify in the config map and secret spec that you want to have immutable config maps of secrets. And in that case, the Kube API server is going to reject any changes to them. You would have to create a new secret before delete the old one, then create a new one, and then recreate any pods using those secrets or config maps. Besides that, we have a bunch of kubectl user experience improvements. My 2 favorite ones is the first one, you are not going to see the server-side apply fields like the managed fields. And besides that, you can now specify the default container to be used for kubectl operations like logs and exec by putting the annotation on the pod. And the next one that I wanted to highlight is structured logging. The working group structured logging did amazing job in 1.21 on the structuring and standardizing logs for all components. Many components are already migrated to structured logging, and the working group is doing some amazing job in 1.22 as well to make the other components migrated as well. If you want to learn more, you can check the following resources. The 1.21 announced blog post, the official one, and the changelog has a lot of details on what's new. And we also have our blog post on Kubernetes blog highlighting the most interesting changes, and you can see the link here. And since that we now seen the Kubernetes 1.21 and what's new, let's see the 1.22. The 1.22 release is currently work in progress. We are at the week 3 of the release cycle, so we have just started. I want to mention that since the release cadence cap got merged, we are going to have only 3 releases this year. The first one being 1.21. We are going to have 1.22 in August and 1.23 by the end of the year, probably beginning of December. Some of the milestones is that we have enhancements freeze at May 13, which is only 1 day away from now. And then we have beta 0, which is going to be June 21. There is also going to be some alpha releases in between. And you can check the release calendar in the Kubernetes SIG release repository if you want to see more details. Then we have code freeze at July 8, where we are going to lock the master branch of Kubernetes for all new feature-related changes. There will be some test changes and reported bug fixes allowed, like maybe for 1 or 2 weeks more until the test freeze. But after that, nothing too big or interesting. And then we have RC0 targeted for July 20, followed by Kubernetes 1.22 release at August 4. And that's basically it for today regarding the Kubernetes community update. If you have any questions or would like to know anything more, please let us know in the YouTube chat or feel free to reach out to me on Slack. Thank you.
Thank you very much, Marco. I will now proceed with the recordings as announced earlier. One second. And we will start with a short talk by Yacheng, who also works as a software developer at Kubermatic, and he will let you know why it makes sense to write operators for Kubernetes. Let's get started.
Hi everyone, my name is Jiacheng Su, and I am a software engineer at Kubermatic. Today I will talk about why to write operators for Kubernetes. So what are Kubernetes operators? Operators are software extensions to Kubernetes that make use of customer resources to manage your applications and their components. Operators can bring us many benefits. It automates operational tasks for you, for example, deployments, upgrades, backups, which are normally supposed to be done by human operators. And it makes your applications more Kubernetes native. You get lots of built-in features of Kubernetes out of the box. You can interact with your applications with Kubernetes APIs and kubectl toolings. It also provides a possibility to test your application operations and takes the error-prone human factor out of your application lifecycle management. Last but not least, the application management in multi and hybrid cloud will benefit the great capability of operators because operators can work with different Kubernetes distributions. A Kubernetes operator can be namespace scooped or cluster scooped. A namespace scoop operator watches and manages resources in a single namespace, and a cluster scooped operator watches and manages resources in the whole cluster. Namespace scooped operator provides the flexibility to run different versions of an operator independently in a cluster, which may be helpful, for example, in case of dev environments or in single cluster environments. On the other side, the cluster scoped operators work better in managed and highly distributed environments. As only one instance of the operator needs to be run in each Kubernetes cluster, it is much easier to manage across many clusters and can save huge amounts of resources in case of many tenants. At Kubermatic, we provide a central service hub with power of KubeCarrier project and cluster scope to Kubernetes operators. KubeCarrier provides multi-tenancy support by leveraging resource escalations by Kubernetes namespace, and the cluster scoped operators can manage service instances across multiple namespaces, which reduces the maintenance burden and the complexities of service management across multiple clusters, clouds, and regions. That's it from my side. Thank you for your attention.
All right, this was the first part. Let's continue with the second one by Rastislav, who was also speaking at KubeCon last week. And he will tell you more about implementing, monitoring, logging, and alerting for a highly distributed platform.
Hello, so my name is Rastislav Sabo, and today I'll be speaking about implementing monitoring, logging, and alerting stack for a highly distributed platform. So a typical monitoring, logging, and alerting stack in a Kubernetes cluster may look like this. We'll deploy several different components into the Kubernetes cluster, such as Prometheus for scraping the application metrics, Loki for doing that for the application logs, Grafana for providing the user interface to access the logs and metrics and the dashboards generated from them, and maybe Thanos and some cluster storage for providing long-term storage of our metrics and logs. So in case of two Kubernetes clusters, we'll usually repeat the process twice and have all these components running in each cluster. But in case of many Kubernetes clusters, this approach becomes really hard to manage. We need to install and set up the same components too many times. And in case of version upgrades, we need to do that across all clusters, which is really hard to manage. So how can we solve this with the Kubermatic Kubernetes platform? Since Kubermatic Kubernetes platform has a hierarchical architecture in which the control plane components for multiple user clusters run in a single seed cluster, we can build our MLA stack on top of this hierarchy. So in the user clusters, we would deploy just the stateless components that would stream the metrics and logs to the seed cluster. And in the seed cluster, we would deploy all the complex components that are responsible for long-term storage and user interface that respects the multi-tenancy, so that every user can access only data for those clusters they have access to. In an even more distributed environment, where we would have multiple seed clusters located at different locations, we would use a similar approach. So the user clusters would contain just the exporter applications, and the seed clusters would store all the data. But as you can see, the data is still located closely to the user clusters. So in the same location, we don't want to stream all those data across the locations. At the same time, we can provide a single Grafana user interface in the master cluster that would allow us to access the logs and metrics across all the clusters in this hierarchy. So to summarize, the Kubermatic Kubernetes platform monitoring, logging, and alerting stack provides the following benefits. Easy installation in the user clusters with a single click or an API flag, or even it can be installed by default into every cluster. Easy data operations and upgrades of the components in the user clusters because they are tiny and stateless. Low footprint for the user clusters, which is especially important for the edge use cases where we run our worker nodes often on resource-constrained nodes. Single pane of glass for even thousands of clusters through which we can access all the logs and metrics across all clusters. And the multi-tenancy support so that authentication and authorization is integrated with KKP, users, projects, and roles, which provides us either per tenant Grafana view for logs and metrics or a global admin Grafana view for logs and metrics and alerts. Okay, that's it from my side. Thank you for your attention.
Yeah, thank you, Rastislav. I wanted to say, but Rastislav is not with us today. But the third part will be taken over by Marco, who you've already seen in the Kubernetes update. And he will talk about how to write software that sets up Kubernetes anywhere.
Hey everyone, I am Marko Mudrinic. I'm a software engineer at Kubermatic, and today I'm going to talk about how to write software that sets up Kubernetes anywhere. This is a story of what we learned while creating a Kubernetes cluster lifecycle management tool called KubeOne. Installing Kubernetes doesn't have to be hard. Kubernetes is a complex system, but we are going to see how we can use existing tools to make this task easier. Let's start with a 10,000 feet view of how should the cluster management tool look like. First, we have a user-provided manifest that defines how should our cluster look like. The manifest is given to the tool, which creates a new cluster based on the provided manifest. This way, we implement a declarative approach, which brings many advantages and is widely used in the Kubernetes ecosystem. The question is, what should our tool do? The Kubernetes community is large, and it created many tools to make managing clusters easier. You should always reuse as many tools as possible, instead of implementing everything from scratch. I want to highlight KubeADM. It is an official Kubernetes cluster management tool that creates production-ready, conformed clusters out of the box. KubeADM does everything Kubernetes. It provisions the control plane, the working nodes, it can upgrade the cluster, manage configuration, certificates, and more. And the mostly important, it works anywhere, on cloud, on premises, bare metal, and more. However, the KubeADM's philosophy is that it only takes care of Kubernetes and Kubernetes cluster management. It is supposed to be used as a building block in other tools and scripts. What about everything non-Kubernetes? For example, infrastructure provisioning instances, configuring instances, installing packages like container runtime, kubeadm, kubelet, running kubeadm itself, and installing add-ons like CNI, metric server, and everything else needed. For configuring instances, installing packages, and running kubeadm, we can use well-established tools and protocols like Cloud Init or SSH. For installing add-ons, we can use kubectl, ClientGo, Help, or whatever else works best for you. However, what about the infrastructure and provisioning instances? This is potentially the hardest problem to solve. There are way too many providers and setups, like cloud with AWS, GCP, and much more providers, on-premises with vSphere and OpenStack, and bare metal, Edge, and so on. And every provider is different. Every provider has different features, different structures, and APIs. And there are also endless possibilities of terms of architecture, which makes the problem even harder to solve. I will highlight the 3 common approaches to solving the infrastructure problem. The first one is to implement infrastructure management in our tool. The second one is to use external infrastructure management tool, for example, Terraform. And the third one is a hybrid approach, a combination of previous 2 approaches. Managing the infrastructure ourselves looks something like we have seen before. This time, the manifest will include the information about how the infrastructure should be created, along with the information about the Kubernetes cluster. The tool will create the infrastructure and instances, and then install and provision Kubernetes on those instances. The problem with this approach is that we lose ability to create clusters anywhere. If our tools doesn't support some provider or architecture, user will not be able to use it, unless we don't extend the tool. To solve this problem, we can use an external infrastructure management tool, such as Terraform. We'll use it to create the infrastructure and provision instances, and then we are going to provide the information about those instances and how to access them to our tool. The user-provided manifest will only contain information about the desired Kubernetes cluster. The tool then could use SSH to access instances and install Kubernetes there. Finally, the hybrid approach assumes combining the previous 2 approaches. We have decided to go with this approach with KubeOne because it offers a lot of flexibility. The external tool is used to create the infrastructure and control plane instances, and then our tool will provision and manage the Kubernetes control plane. Then we implement a cluster API-based Kubernetes controller that is used for managing working nodes. That way, we can manage our working nodes using the Kubernetes API and use features such as autoscaling and more. That's it for today. Thank you for your attention.
All right, that was the inception part of our live office hours. I'm excited to see the recording later on how this looks. And now it's time for questions. Are there any questions from the YouTube channel? Apparently there are no questions. All right, if you have no questions, then we will end the session now. Thanks again for joining, and then hopefully see you at either like our next office hours or one of our webinars. We regularly try to share our knowledge. Or just enter discussions with us via Slack, on GitHub, or wherever. We are really looking forward to that. And I wish everyone a nice rest of the day. Goodbye.